All right, welcome back. We are Game 2014. That's a mobile game dev 1 in the fall 2021 semester at George Brown. And it's week 10, part 2 of our broadcast. And last time what we did was with our Unity project, we made our player dance around a little bit, as well as kind of connect onto a moving platform. And this time around, we want to give them a few challenges. And we want to start off with developing an enemy AI, which is going to take us the rest of the time today. All right, so a couple things first. First things first, let's grab the link for the video and put it up on Blackboard. Hopefully Blackboard hasn't signed me out yet. Maybe it did. Let's see. It did not. So we'll say that this is the part 2 video. There we go. And let's get into this. All right, so what we want to do is kind of add some enemies. First, we need the enemy to add, and let's add another platform as well. So just like we did before with our worlds, we went to the platform layer, we go to the top palette, grab this platform, and let's add another platform somewhere else in the world. Let's suppose this goes up and down. We want it to go somewhere where it's impossible for us to get to right now, which is something like this. And let's say at the top of that platform, we're going to have an enemy to defeat, maybe some other things to pick up. We'll see how this goes. So let's see the layout. Again, we're going to start here because to make it so we can get on top of this. So how about we do the right kind of moving platform? So the moving platform in this case will be a vertical one. There we go. And we're going to say that it's going to take us up here or above that, and we can jump down on it, right? It's going to be looping. So jump up on the platform without dying, Tom. There we go. And now we're on this platform, and this is where the enemy is going to be. Okay. So what we want is, for now, the enemy is going to appear on this platform here. And by the way, if you don't like it, if you want to make it wider, longer, whatever, that's fine. It might be a good use case. We want to put the enemy on here, and we want them to basically move around. Let's take a look at some external assets for the enemy. Which ones are we going to use? So let's go look at Sunnyland first. And we look at the artwork sprites. We can see that there are enemies. There is an eagle, a frog, and an opossum. The opossum is interesting, right? As it crawls on the ground, the opossum. That's pretty cool. And I think it's got the most movement frames. It only has movement frames right now, so this might be an excellent time to put it in. I want to change the pixels per unit to 16, right? And then also change the resize to bilinear. This is the one I like. And reapply and drag and drop the opossum in place. It's going to ask us to put together a animation controller. So just like we did before, I'm going to go to sprites, animations. In this case, I already have the player animation. Let's add a new folder for the... Oh, I love it. Doesn't allow me to do that for I love Windows. And that's fine. We'll just call this, we're going to have a bunch of extra folders. We're going to call this thing the opossum, or we'll call this the enemy for now, run clip like this, and put that into place. Let's see what craziness it did to me, right? My weird stuff. So animation, and okay, let's add in a new folder. We'll call this the enemy animation, and we'll grab the opossum one and the enemy run clip and drag it in there. And we'll make a brand new folder for the player. And the player's animation and all that stuff is going to be in there. Awesome. Cool. The other thing we didn't do so far is we didn't make the player a prefab. That would be terrible if we're going to go to the next level, and all that stuff we did with the player is gone. So in the prefabs folder, I'm going to drag and drop the player in there. Okay, so we have the player prefab done. Save. So again, the opossum is really going to be the enemy. It's going to have a simple animation that is kind of comes with the enemy. So if I was to kind of add the opossum in place, right, as an example, and I ran the opossum as it is, you're going to see the run animation kind of playing by default. There it is. So it's going to run like this, right? There we go. We need a couple things for the enemy, but first let's go and fix the sprite for the animation. And we don't want to call this opossum 1. Let's rename this to enemy animation controller. There we go, a little bit longer. And let's take a look at that. We'll call this the run clip. We don't have a die yet or something else, but we can totally add something else later on. Cool. So that is this. And let's go back to the scene. And we want to add some stuff to the enemy. One thing we want to add is a collider. So let's look at a proper collision shape for the enemy. And if you notice that they're pretty big, right? We only really care about hitting them here, but we could, do a bunch of things. The easiest one would be to add a box collider, right? That would be the easiest thing to use. And we could size it, okay, so that it works for the enemy. The key here is it should be fairly close to the feet of the enemy so that the enemy kind of appears to be on the platform. And we don't care much about the tail. Tail can kind of be something we can't collide with, but we can kind of land on top of the enemy maybe as well. Okay, so that's something we'll be able to do. So that's one option. The other option is to split the enemy down into different pieces or make it so that the collider hugs the enemy a little differently. One suggestion that has been made by different people is, if depending on what you want to do with the enemy, are you going to allow the player to jump on top of the enemy to do damage to them, or what are you going to allow? These are topics for another day. For now, what we want to do is add in a rigid body. So let's add a rigid body in there, right? So again, if the enemy falls, we can simulate what that's going to look like. So rigid body 2D. And we definitely want the collision detection also to be continuous, right? So that way, if the enemy falls, we have good detection. Gravity scale, remember that if we use the gravity scale as low, we care about the player falling properly. But if the enemy falls slow, it's okay, right? That doesn't have to be the same as the player. So we don't have to play as many games, right? So let's see how that works. If we were to add that in, will it hug the platform? So again, you can see that, yes, it kind of stays on the platform, and that's pretty good. And if we were to take the enemy and drop them, they're going to fall, but they fall pretty, terribly, right? See how they're actually falling every single time? This is the same thing. We're going to have that parenting idea with the platform along with the enemy, right? So that's kind of something we need to do. Let's add an enemy controller script. So create a C# script called enemy controller. There we are. And let's attach it to the enemy. So let's do that. And let's double click on the enemy controller script, and let's go into the enemy. Okay, so the enemy starts where it's going to start, right? We know that if the enemy connects with the platform, right, as an example, then there's a couple things we wanted to do. We want to do this private, actually, let's just copy and paste what we had from before from the player, right? Because we have the player behavior. Let's grab these last things that we have here. And these are pretty good. Let's go with the enemy controller and paste them in. And we can say that if the other object is a platform, then let's transform set it to the platform and do that whole parenting bit that we did before. And now we can test that out. And what we want to do is, as we're going, I think it's a good idea to grab the enemy and make it a prefab. So you could add more than one, right? And we're going to do with the enemy, there's two pieces what we want to have. We want to have a look ahead, the ability for the enemy to kind of scan to see if there's any ground ahead. And if there's no ground ahead, then we want the enemy to switch directions and move back the other way. Okay, so that's kind of something we want to do. All right, and let's think about how this is going to work with the parenting stuff that we're talking about. So if I kind of go here, yay, and if I look at the scene, we can see that it's moving. But if I was to grab the scene and then drop the enemy down, then you can see that it's moving nicer than it was before. So it's not jumping around or any of that stuff. Again, the challenge is, do we want to make the rigid body, what do you guys think, people that are here? Do you guys want to make the rigid body, the gravity scale, the same as the player? What are your thoughts? If you're the designers, what would you recommend? I'm asking for the people here that are in this section. So again, we're sitting with the player at 0.1 in a gravity scale of 10. Should the enemy theoretically be the same? I mean, it doesn't really have to be, but if you even did it, if you said the math is 0.1 and the gravity scale is 10, the motion would seem very similar. And I think we don't have to do this, but I can, just looking at it now, the way it falls, I think it's just more natural looking for everything to fall in the exact same way. But then we can kind of go with someone else's suggestion, which is, well, if you're going to do that to everything, then you might as well set the global gravity scale to what you want, and there's less calculations. So far, just the enemy and the player. So the enemy is going to move ahead, and it's going to move. There's a couple ways we can do that. We can add force like before. Problem with adding force is we'd have to add it in an interval. Or we can reposition the enemy. So there's two different ways of doing it. And again, this goes back to what we talked about before. Do you want to set the velocity to something? So remember, because we have a rigid body already and it's falling, setting the velocity would be similar to what we're doing with a platform, what you were talking about, Kira, right? So let's go back to that enemy controller that we had here. What is this that we have? Oh, yeah, it's this thing. Just want to make sure. I think we should probably kill this just to give us more. Right, and so let's think about this for a second. So we want the enemy movement to be here. We'll call this a private void function called move enemy. And we'll call the move enemy function here. Okay, so then how would you propose adding in velocity? So if I said something like, well, I want my rigid body to be a private variable. If I did this way, I can say that rigid body is equal to get component rigid body 2D. And then in move enemy, I could say rigid body dot set. And it's really the velocity is what I want to set. So we have get, and we can actually set the velocity to wherever we want. We can say velocity is equal to whatever it is, right? And what we can start saying is, I want to move it towards the left, which is where my enemy's pointing. It's looking to the left in this particular case. And, or depending on which direction I'm facing, which is something else we have to think about, right? And as I'm moving this way, I can add velocity, right, as an example, to the enemy every interval, as an example, if we want to do that. Or instead of doing this, I can just say the transform dot position is changed. My transform position is going to be some added value based on, so plus equals to a new vector3 object, which is going to be something like a the direction that I'm moving in, right, multiplied by my my speed. So I need some kind of speed, which will be a public value. Actually, I'll need this even if I'm using velocity. So we'll say public float, and we'll say this is called speed, and we'll use the header that is going to be movement. All right, so the first thing we need to do is actually move the enemy. Okay. And then what we want to do is we want to be able to start thinking about AI and some simple ways of doing that. Okay. So again, that is the first, I think our first job, if you will, is to start moving the enemy around, which is something that we want to do. All right, let's take a look. So, so a couple things we can do. We can do a move, right? When we move the enemy around, and the transform position will be this new vector 3, and we want some kind of speed. So we'll add the speed, and we'll multiply it by some kind of direction. So we'll say that the public float direction is going to be also something we care about, right? So 1 or a -1. Again, I'm not sure that I want to make this public or private right now, but for testing purposes, we'll do that. So we'll say speed multiplied by direction, right, across the x-axis, and multiplied by time dot delta time, because we're inside of the movement or update function. And then what we want to do is something like 0.0f. So even though it's a vector 3, all we need to do is provide it 2, and the third one will be 0 by default. All right. The reason why we need to make it a vector 3 is because we can't do a plus equals with a vector 2. So this is kind of the transform that we can do. This is our move enemy. So again, what we can do is we can think about creating a horizontal boundary, right? So there's a couple things we can do. We can say when the horizontal boundary gets to a certain point, swap directions. I want to move to the other way, the other way, the other way. And we can kind of figure out where that horizontal boundary is, and that would be grand, right? But the challenge with that action would be that if we're going to do some kind of check boundary, then when we move across, let's go back to this, we'll move across the platform, then how would you set that boundary? Because all platforms may not be the same size. Maybe I'm going to put a platform, enemy on a moving platform. So having a check boundary where I say, check between this and then move the other way is kind of not something that we want to do. But there's definitely a solution. It's not maybe the perfect solution or the right solution, but it's something that we can actually do a little different. Okay. So that is definitely a way of doing it. Okay. So we can do it with the move function a little differently than what we've done before. So we can definitely do a couple of other things. I can add force. So I can reposition, right? So if I did the repositioning, going back to what we have here in the controller for the enemy controller, we can continue doing this forever, right? So clickety click, clickety click, and then it'll move. This will move actually backwards for what it'll look like the enemy will be moving backwards. So if I kind of click on this thing, you'll see that, raycast is definitely what we're going to do, right? So if you look at the scene, what we want to do is we want to enable the enemy to move in a particular direction. And why is the enemy controller 0? Did we not save? Raycast is definitely the way to go. But our speed cannot be 0. Let's set up a speed of, let's say something slow, 0.1. And the direction will be, for now, -1. So the direction will be in this direction. Okay, so we could do this way, right? I'm just talking about, ways of doing the same thing, right? So we can see that the enemy is moving slowly, and we can increase the speed, right? So it looks like the enemy is moving. And then when it gets to the edge, we could put a boundary, but that would be bad, right? And eventually it'll fall and keep crawling to its death, potentially. Let's take a look if it'll even make it. That kind of made it, right? Let's see if this just little thing will kind of make it. So yeah, it did, but then it'll also do this, which is kind of weird. And that tells us that our rigid body for our enemy should definitely have a constraint. that freezes across the z-axis. So definitely something we want to do. Apply all. Make sense? So yeah, we could definitely do that, and it's not terrible, but maybe what we want to do is we want to do the same thing that we've done in the past, which is use physics. Okay, so that might be a better solution for us. So if we're going to use physics, we want to think about a couple of additional things than we had before. One, we do need a rigid body 2D for sure. Instead of speed, right? And we're just going to get rid of this, okay, so we don't get any errors. Instead of speed, what we want instead is a force, right? So kind of like a horizontal force, or let's just call this the run force, right? So that's what it'll be. Okay, a run force. We want to have a position which is kind of like a look ahead point, a place where we can look in front of us and where we're going to cast a ray. So some kind of look ahead point. Okay, that's what it's going to be, and we're going to make this a transform. So that's what the look ahead point is going to be, and we're going to show this in the editor in a second. I also want to check for the ground layer, because remember, we're going to have probably a layer mask just like we've done for us. So public layer mask, and we're going to say that the layer mask we want to collide with is the ground layer mask. So ground layer mask, okay? And we want a public Boolean, which is ground ahead. Do we have ground ahead of us? And I think that's where we can start. Okay, those kind of movement variables so far. Instead of using update, just because we're using to simplify things, we'll use fixed update again. And when we move our enemy, we'll have a couple of additional functions. One of them will be a look ahead function. So private void, right? Look ahead function, look ahead, where will allow the character, the enemy, to look ahead and see what they're seeing. Okay, what's like kind of ahead of us? Is there any ground ahead? If there's no ground ahead, well then turn around and go the other way. That's what we're going to do. Okay. So again, some simpler ways of doing this. But the ground layer mask is going to be looking at the platform. So let's kind of configure that now. So for the enemy, right? What we're going to do is, let's just kill this, is my run force has to be a number. So let's, again, just like we did for the player, since the player and the enemy are similar, it should be the same as the player, something like between 5 and 10. All right, so let's just use something small, like 5, right? So we're still adding the add force. The look ahead point is an item that's going to be something inside of the enemy. So we're going to add an empty, right? And we're going to put it inside of the enemy. We're going to call this the look ahead point. Look ahead point. Let's focus on that enemy for a second so we can see what we're talking about here. And the look ahead point, we're going to tag it with a little dot, maybe a diamond. And we're going to kind of look ahead in this direction. So there's the look ahead point, which is going to be below the character and down towards this direction. Okay. And we want to draw a line from the character's middle to the look ahead point. So let's do that inside of the enemy behavior itself. So going back to this and going back to the bottom here, we want to use on draw gizmos, just like we did with the player. So under player behavior, we had this on draw gizmos utilities. Actually, this should actually be down over here. And this should be part of the events. So these are events. So this utility, I want to do the same thing, but I have a color green for draw gizmos already. So all I want to do is draw this a wire, right? So, but we're going to copy this anyway. So back to enemy controller, pop this down here, and call this events. And inside our events, we don't want the ground origin position. We want the look ahead position. And we don't want to draw a sphere. We want to do some kind of line. So we're going to say gizmos dot draw line. And it's from, which is the transform dot position. That's the middle of the character. To, which is the look ahead point dot position. Okay. So that's what the line is going to be drawn. And let's see how it draws it in the scene. Well, we need a look ahead point. So in the enemy itself, we're going to drag and drop this look ahead point and put it here. And then we can see a line. By default, unless we say so, for each object, we have to decide on the, with the line color. So let's make the line color green, just like we did before. So we can say, just like in player behavior, we can take this green color and put it here inside of our gizmos. And it instantly changes in the editor. There we go. So now we have kind of a position, and it goes from here to there. And that's kind of represent our raycast, right? And I'm doing this so we can visualize what we're seeing as well. So first, in fixed update, we're going to look ahead. And we're going to see if there's any space ahead of us. And then we're going to move the enemy, right, in the direction that we're going. So let's think about that look ahead. We want to use some kind of hit, which is, and we can use a raycast, or there's a 2D raycast called a line cast that's actually a little bit apparently more effective. So we could say var hit is equal to physics 2D dot line cast. And in the line cast, we can use the transform dot position and the look ahead point dot position. We can use the ground layer mask as the layer mask. All right, so that's going to determine if I'm looking ahead, and when I'm looking ahead, the endpoint is a hit. Okay, if we have a hit, then what I want to say is, we'll just do it for now. We'll do a debug.log that says there's ground ahead, right? And if we don't have a hit, right, we'll say that there's a debug.log for now that says there's no ground ahead, or no ground ahead. Okay? So we know that this would work. That's what we want to do. So we have a hit, physics.raycast from the middle of our character to our look ahead point. We're using the ground layer mask. What's that ground layer mask? We never configured it. Let's take a look. And we can see that the ground layer mask is nothing. We can configure it to platform, right? And pirate opossum, yeah, that's right. And let's see how this works, right? Does it work at all, as an example, or not? We haven't told it to do anything right now. It just says no ground ahead. And then there is ground ahead. So no ground ahead, right? When I pull it up, look, and there is ground ahead. So we want to say when there is ground ahead, we want to turn this on, right? And that's what we want to do. So that's the first thing. So is there ground ahead? What we want to say is when there's ground ahead, we want to, again, this is looking ahead. And if we'll say is ground ahead is equal to true, Okay, and else is ground ahead is equal to false for now. So that's going to detect whether it's true or false. Now, there's a way of doing this where you can do this in one, of course, and the way we would do it is something like this. We can say is ground ahead is equal to hit, true, false. And you can save all kinds of time with the ternary operator. In fact, it tells us we can just remove all this already and just say that is ground ahead is equal to the hit, right? So let's see if how that works. We can expand that later. And again, if we were to run it and go back to the scene, we're not moving yet. But we can see that is ground ahead is on, and then it's off, and then on, and off, and on, and off, which is pretty good. That's exactly what we're looking for. So we can detect ground with the opossum. All right. So now the next part is the move. And this is where we want to check to see if there is ground ahead. If is ground ahead, then what I want to do is say that my rigid body dot add force, and I want to add force in the, we'll start off with vector2 dot left, right? Multiplied by the run force, multiplied by, I mean, I don't know if we should scale this at all. I don't think scaling is required at this point, but we'll see. Maybe it's going to be too fast. Multiplied by my transform dot local scale, because we want to use the local scale dot x, as an example. So where the transform local scale dot x is the whether we're 1 or -1. Okay. And right now we haven't flipped things around, but we will eventually. So that is whom marching us along, and so on. And what we want to think about is when we get to, we also want to slow us down a little bit. So every frame, because we're adding force, we want to use that rigid body dot velocity, and we'll say that that is times equals to 0.90. Let's say really kind of slows us down quite a bit. So it pushes us, but it slows us. So that's if ground ahead. If not, then we want to do is we want to have another function, which we don't have right now, and we'll call that flip, kind of like we did in the player behavior, where we had our flip function, right? We had a flip animation, but now we're just going to call it flip. So private void flip. So what does this do? And again, pretty straightforward stuff. We're going to say that the transform dot local scale is equal to a new vector3, which is the transform dot local scale dot x multiplied by a -1, and then we're going to keep the transform local scale dot y, and the transform, we have to do this, dot local scale dot z. We need to do this right away. So that is the way we would transform the local scale, whatever the local scale is, depending on if we need to flip or not. And that would be on the else. So we'll say if we don't have ground, then flip. Okay, which is going to basically be flip direction. Let's see if this insanity works, right? Because that's the first piece of our little enemy. Can we move around and can we flip around? So let's add that in. And run. Maybe it's too fast, but no, it's pretty good. Right? It'll flip around and move around until it goes forever. Thoughts around this? Is it okay? Is it not okay? What are your thoughts, guys? Since you guys are the only people that are here right now. I mean, really, at the end of the day, yeah, I mean, it's going to continue, right? So what about, how does this present an issue? right? Well, one thing we can do is, can we detect that can we kind of create a line of sight as well, right? And what happens if there's some kind of obstacle ahead of us? This is interesting. But what if there's like a block or something ahead of us? Right now, it's going to try and push that block off the screen, right? So let's add in a obstacle or whatever. And let me show you what I'm talking about, right? Because it's not going to stop, right? Oh, look, it did create these extra folders after all. Goodbye folder. And goodbye folder number 2. That was weird. Unity's been really acting up for me lately. So yeah, so if we, what I mean by this is if I go to external assets, Sunnyland, and if I go to environment props, and if I look at like something like a big crate or let's look at a block, this block, and let's make this so it's scaled properly. So 16, and we'll put in a value of bilinear, and we will apply the changes. Is the application button? Oh, it's here. We'll apply the changes, right? And when we drag that block into the scene, here's the block, right? There it is. And let's add some stuff to it, right? So we'll add a collider. So rigid body. Well, actually, we'll do a collider 2D. There it is, box collider 2D, which is the same size as the crate. There we go. And we'll also add in a rigid body. In this case, we don't care about limiting the rigid body to fall, but we'll change the gravity scale. I shall leave the gravity scale as is for now to see how it looks funny. And if we put this in place and we watch it, then we can see that when it gets to the crate, it stops. And it stops for a couple of reasons. One, because our crate actually has a mass of 1, and our little opossum has a mass of 0.1. So this is why, again, going back to what we were talking about before with the block, and let's just, for now, let's just make the block a prefab so we can use multiple blocks if we want to in the future. So let's add that block in. And it'd be nice if we rename this block, maybe make it a block, which is something like this. Hey. And this block right here, we can change the rigid body, make it so it's 0.1, same as the opossum. And we can change the gravity scale to 10. So it does not winged off. So same idea, but we're not going to freeze the rotation. Let's see how that works. Can the opossum push the block around, or is it going to be stopped? And I'm talking about this because what if, right? What if it can't be pushed? Then the opossum is stopped and it can't move back. So that's an issue. Again, if you drop the block, it'll drop like a stone, no problem. That's no problem. But the thing is, it's still, gravity scale is pretty high. So let's drop that gravity scale down to 5, which is still pretty good, but not as crazy as the opossum's gravity scale or the player. Let's see if the opossum can now push the block compared to what he did before. And still not much, right? And the reason for this is because remember that the block itself, right, is using the same friction as everything else. So we can add a material for this. So create a new 2D physics material 2D, and we'll call this the block, right? And we can say that the block, well, guess what? It's got a material of 0.1, right? So very friction, kind of a lot less friction than the rest of it. Does this make a difference as an example compared to everything else? Well, we want to push that as part of its material, right? And let's see if that makes a huge difference or if it doesn't. So Physics 101 says that we should probably be able to push the block now a little bit more than before. And you can see as slowly, the opossum can push the block. By the way, if the opossum can't push the block, neither can the player, FYI, right? Because the block itself, even though it's got a friction of 0.1, is enough combined with the friction that we get from the platform, because the platform's friction is like 0.4, to stop things from happening. And also the amount of force that we've given the opossum to move is enough where the block won't move very fast. But what we could do instead is, if we want, we can get the block to be pushed. When I'm in game mode, my opossum is invisible. I can see it fine in the scene mode. Oh yeah, that's weird. That's a glitch and a half. Try and adjust your view, like actually zoom in and out. That's totally strange. Your opossum shouldn't be like that at all. And also check its, one thing we didn't do with the opossum, the enemy, is in the sprite render, make sure the order and layer is the same as the player. We didn't do that. So let's just make sure we override and apply all. We haven't done that, so the enemy should have the same. So that is definitely an issue. So the issue that we have is our block can be pushed if we wanted to, very slowly, but it will be pushed, right? And it's being pushed by the force of the opossum, right? So that's something. What we also want to talk about here is, what if we don't want the block to be pushed, right? And we want the block instead to have the opossum stop. Whenever we hit a block or another object, it's going to bounce the other way. So this is something that we want to do today, right? So how do we do that? Well, we can actually look ahead or look in front as well as look ahead. So we can have the enemy having both capabilities, right? So this proposes that we have two ray casts, right? A look ahead point and a look in front point. Let's do the modification of the scripts now. So enemy controller, and we want to say is we want to have another point. So this is movement, right? As an example. So we'll say that there's also going to be a public transform, which is a look in front point, a look in front point. And for that, what we need is another object. So let's do that. So we'll say Control D, right? There's the other object. We'll say that this is a look in front point. Look in front point. And this is the last thing we'll do. So we can either look in front or look ahead, look in front, and we'll make the point the same, but this time we'll kind of make it rise over here. So whether it's in front of the character, we can make it so that it's just when the character hits, it's going to turn around and go back, right? Not a collider necessarily, but a look in front point. And let's draw a line from that way as well. So just like before, we can use our utility. So we can draw a line from the transform position to the look in front point. Okay. It's not working. Look in front point. Did I make it? There we go. And of course, this is going to cause us to have an error because there is no look in front point right now. So what we can do is we can go here and attach it. There's our look in front point. And we can clearly see that we're looking in front as well as down. So just like we've done with with something below us, we can also look in front of us. And we can have another function, right, that does both look ahead and look in front. So look in front. We don't have that function, but we'll get it. So we'll do a private look in front. Right now, it doesn't seem logical that we'll have the same thing or not, but you know, it's pretty much the same as what we did before, but now what we're colliding with is something else, right? So instead of us colliding with a platform, right, what's our layer mask, right? It's something like a wall or something else. So ground layer is one thing, but what about some other kind of layer mask, public layer mask, that we can use instead of a ground layer mask? We can call this like a wall or a block or something like that. We'll call this the wall layer mask, right? And whether it's a wall or whether it's a block, right, it's going to be something that we select that's in front of us. This is tricky, just FYI, right? So we can do the same thing as we did here when we did our look ahead. Grab all this. And we can say that we're not grounded anymore. We don't care about this piece, but we do care that the hit is the transfer position with the look in front point. Okay, so the look in front point position with our wall layer mask instead of our ground layer mask. What's the point, you're going to ask yourself? Well, if I hit the wall that's in front of me, if there's a wall hit, then what do I want to do? I want to flip, right? Again, you could make this different, but one thing we need to do is to configure what the wall will look like, which means the block is going to actually have to have some other layer other than platform. So add layer, we can call this the wall layer, right? Or call it block, whatever you want to call it, right? And for now, we'll call it wall, because that's kind of what it is. We can build a wall from the blocks if we want to. And this is interesting. What we can say is when the enemy hits a wall, and the block would be part of that. So we'll name this as a block. There we go. When the enemy is a wall, and we'll just do the override, we'll add all that stuff to the block prefab, and we'll add all this stuff to the enemy prefab, right? Then it will hit the wall and come back the other way. So why is this good? It gives us more options, is what it does for building, right? So let's try this out and see how that works. Also, slowly, if I'm not wrong, when the opossum hits the block, right, depending on how we hit it, I mean, we can reposition this block in real time anywhere we want, right? We can make it so that the opossum turns quicker, right? Or way longer, okay? So kind of a control of, kind of things in both ways. Here's something else. If we want the opossum both to turn and to hit the block, then all we need to do is we can turn the look in front point and move it closer so that it's within the enemy's collider, but just barely. So again, it's kind of a tricky thing that we want to do, right? So we're going to say that here's the enemy's collider, right? All right, I want to see this. And let's just, for now, we want to keep, well, let's keep this inspector on for now, right? But what I want to do is the look ahead point itself, right? So, or the look in front point. There's a look in front point. I want to grab this look in front point and just go a little bit in on the collider, something that like right there, okay? And maybe even just a little bit beyond. So when it hits, as an example, I want to use the forces that I normally get with a collider plus bounce back the other way, okay? Let's see if that works. And you're going to see that it's going to be a problem. So march along and no hit. And no hit. If I want to apply force, then what we can do is we can detect what the object is hitting. Because remember, the way this is working is, oh, look at that. Randomly, I didn't even do it. It stopped hitting, and then it turned around. How'd that happen? That's what I was hoping for. Let's try that again. So I didn't do anything. I just want you to think about this for a second, right? So it was working, and then suddenly it didn't work anymore. Watch. So it kind of rebounded, and it rebounds. So y, and I want to talk about this for a second, y oh y is suddenly this not working. Nope, there we go. What's the thing that's causing the little opossum to push the block out of its domain, right? Well, it's because of the random nature of the movement. Remember, we're pushing the object, right? As an example, we're pushing the opossum, as an example, a certain amount of force, but it's not perfect every single time. And we're close enough so that where the raycast is and where the collider boundary is very close, like super close of where this is. Look, it's almost exact, right? And because this is happening, sometimes what happens is the boundary will hit before the raycast. And now physics is taking hold, right? I'm telling it that there's a collider that you should turn around. But what's happening is the raycast fails because the collider hits first, because they're both using the physics system. Okay, so that's kind of an interesting way of doing things. It's random and it may not always work, but it's interesting the way it works. Okay, so we can add as many of these enemies as we like, and we can put them in different spots. So example would be, hey, let's get another enemy prefab, and let's drag them somewhere else. So we can put some enemies around. And what happens when, the enemy hits the player? So let's take that enemy and put it in the same spot as the player. So here's a player spawn point. Let's actually put the player spawn point a little back, like over here on this platform. But what happens if, when I drop down here, what does my enemy do to me, right? So let's think about this for a second. So let's run it. So here I am, and enemy's running around, and then I jump down with my thing, and if I land on top of the enemy, I'm done. Here's something weird. The enemy can't march along because I'm too heavy, right? I've got a weight of like 10, and the enemy can't do anything about it, right? So that's a problem for me to land on the enemy. So again, solutions for this is not allowing you to stay on the enemy's back like this as well. And that means either a second collider, right? Or a different collider shape, like some kind of capsule collider for the enemy, right? But pointing in a different direction. Or a second collider up here that kind of doesn't allow the player to kind of jump on the enemy's back, but rather makes them slide off. If you look at the collider that we have so far for the enemy, so if I look at the enemy itself and pull up the collider, let's uncheck this box. So click the enemy, look at the collider. Then you can see that the collider, when the player goes on the enemy's back, that's an issue, right? Player can't stay on the enemy's back, can't move, because the only way the player moves is because they're raycasting, right? And the enemy's kind of sitting on top here. So one thing to do is to reduce the size of the collider. So when the enemy hits, that's cool, but make something else, another collider shape on top here for the enemy. Again, it's just tricks, right? But think about what you'd want to put in for a collider shape. So remember that there's different kinds of colliders, right? And we could use some kind of polygon collider if you want as well, right? So if I want to draw a polygon collider, right? Or let's undo that change. Let's add an edge collider. So here's an edge collider. And let's go back to the enemy for a second and modify it. Where did it go? Did I put it on the player? Wow, that is wacky. Let's do it again. Edge collider. There we go. Here's our edge collider. I wonder where that went. Oh, it's on enemy 2. That's where enemy number 1. That's where it went. Cool. Okay, so let's, it doesn't matter where we do it because we're going to modify it. Let's go back to this enemy and take it away, remove. It was on this enemy. Yay. Okay, cool. And so the edge collider we want to do is we want to modify it. So if we click onto it, I want to move it. And so we can create a shape that we want, right? And this is combined with the other collider. So we got to be careful. We can make this collider any shape we want, something that looks like this. And we definitely wanted to make it so it doesn't combine or bug the other one. So the regular box to box collider, you can see that this is a problem. So we don't want that to happen. So no touching. Okay. Something that looks like that. That is okay. All right. It's weird, but you can totally do something like that if you wanted to. And we can override and add them in. And if I go to the enemy and if I don't like the position of the collider, I can definitely move it up. There it is. And do it again. Okay, so there's my edge collider. And let's see how this works. Does it work? Am I crazy? What's going on? I know, it's crazy. So I jump on the opossum's head and I slide off. And then now what happens? Character's too heavy for the opossum to push, right? And the opossum doesn't do anything. And I can't really push the opossum either. I can jump, but as soon as the opossum hits me, then good luck moving me. It's not going to happen. A couple of things we can do for the enemy is we can increase the force. But be careful about this because that might be too much, right? And let's do that, or increase the mass. One of the other thing we can do is increase the mass. Increase the force, increase the mass. Now the opossums are running, man, like crazy, right? So run force is 10, but then what we can do is we can increase the mass of the opossum as well. So if we go to my enemy number 1, and if we increase the run force to 10, then we want to definitely go with the rigid body. And increase that to, let's say, 0.2. Okay, so that's for enemy number 1. Let's try that and see if that's different. We're tweaking some of the numbers, then we'll stop for the day. So, right? Doesn't make a difference. So double the amount of force that we had before, and it's not quite enough because our our mass is 0.2, even though we've added the gravity is 10, the run force is 10, but we're also double the mass. What if I chose to make it so that the run force is, again, our mass would be something else, right? So let's suppose that the mass is 0.17, something else. Let's see how that works. And again, moves a little bit faster. And if I jump down on here, it can move me a little bit, but not much, right? Again, it comes back down to my, the friction that's happening, right? When I first got pushed, I got pushed because, the opossum touched me. But if I want to push the player off, then I have to keep playing with the mass. Great thing about this is it won't allow the player to come on, and we're not using it for any other purpose. So again, we can play with these numbers again and again. I would recommend some caution. Like the more you reduce the mass of the opossum, then the less the opossum will be able to push, although the run force will be greater. Right? So again, it'll move faster, but then when I hit the ground, there's only so much that the opossum can do, but eventually, given the right numbers, then it may be able to get me out of here, right? May, especially if it hits me the second time, right? So that's something that could happen. It can be kind of annoying. And that's kind of the first enemy, right? There's, line of sight is really in front. They can see very limited sight. They're kind of blind, so they can see in front. They can see that there's something in front. We're going to bounce back if it's something like a wall or an obstacle, right? As an example. And if there's ground ahead, that's great. If there's not ground ahead, then we're going to move past. And if we're not grounded, one thing that you're going to notice is if I put the opossum over here, it's not going to know what to do. What if I take the enemy now? Here's something else, and I take the enemy And what if I move this last thing I want to ask you, and I move it here? So I move it here. What's going to happen there? So if I did that, right, and this is something we have to also deal with, right? Because what happens to the enemy? Well, then now, if I do that, it kind of falls. This is good, but it kind of doesn't know what to do, and it freaks out, right? So what happens if you push the opossum off somehow, right? So again, if I take it over here, it's good, but as soon as the opossum leaves the thing, it just falls. So that's something that happens. And it just freaks out, doesn't know what to do, it keeps on shifting back and forth. So really what we want to do, the last thing we want to do here is in the death plane, if we ever are able to drop the opossum or if he falls off, as an example, is let's take a look at the scripts and go to my death plane controller and say, well, what if the other object is not the player, but rather, right, if the other game object compare tag, we can also do a switch case if there's lots of different kinds of objects. But it's not that, but actually the enemy, right? If it's an enemy of any kind, right, or we can just say else, how about this, else, anything else that hits us, we don't want to retarget, we just want to turn it off. Other.gameObject.setActive is equal to false. Turn it off. We don't care about it anymore. All right? So that kind of makes it so if something falls off, then it's going to turn off. Okay, so let's try that again. So if it falls off, it's going to turn off. So pretty cool. And that's how we probably want to play it. So it falls, good, but you know, what happens? We want to make sure it turns off. But again, by playing with these numbers, all right, with the you know, the stuff that we're talking about here, right? All of the enemies, right, that we have, whether it's enemy 1 or enemy 2, you know, is going to have those two things, the look ahead point and the look in front point. If we collide with some kind of wall, you know, eventually what's going to happen is it's going to bounce back, right? Or the beginning, it's going to bounce back. Let's see what happens now with actually the block. It pushes it right off. Isn't that awesome? Because there's more force involved with the block now because they're moving a little bit faster than what we had before. Okay. And when it pushed it off, notice that it also pushed it into oblivion. So it bounced and goodbye, right? It fell and it disappeared. All right, this is a great place to stop. I think we've done prep for the next session, which is going to mean more AI stuff. Right now, the enemy's movement is very simple. It detects stuff in front of it on the platform and allows us to move back. Some stuff to check is, what if I have more blocks? You know, as an example, can it move both blocks? How much force does it actually have? And some other things to explore are things like, you know, if this thing was to move, isn't this neat? They can kind of push both blocks one at a time, and this can be part of your ongoing puzzle that you kind of, you know, make the opossum fall or summon an enemy, and then the enemy can figure out what's happening. You can also make it so that this platform here, what if this platform is not just there, but actually, oops, undo. The platform, what if the platform actually is a little bit closer, right? So will it detect, you know, will the opossum detect the platform, you know, in the right timings, right? It'll stop, but will it be able to go and join the platform at some point? Like, will it actually go on this one? And depending on how you do it, right, it might work where the platform timings are such that, you know, eventually it's going to cross over on this side. So things to note. All right, that's enough for today. So we got a moving platform. We've got some really cool stuff happening. And let's go file, save project, exit. And for those people watching for the last part, if you add your your enemy and you make them move around the platform like that and do the things that I did, that's your lab 7. So pretty cool. At least a good start. So view changes, we'll say we added enemy, and we'll push this to commit changes, and we'll push it to GitHub. Any questions from the people that are here? Do you screenshot the window game in Unity? What do you mean by that? Do I screenshot the window game in Unity? Oh, you're talking for Lab 7. Yeah. Yes, that's what you would do. Just add screenshots to Unity. So from Unity itself, not from a build. You don't have to do a build for today. All right. Absolutely. Thanks, Michael. Sorry, I was trying to figure out what you're saying. All right. Any other questions? And if not, then see you next week. And thanks so much. And I'll stop recording this one.